Lesson 11-1 of your orange math book is all about how to read a line plot. A line plot is a line in which we plot points. The points that we plot on that line represents an individual instance of that value. So these are lengths of fish caught. There are no dots at 6 inches. And so that means none of the fish that were caught were 6 inches long. There are no dots at 7 1/4 inches. And so that means none of the fish caught were 7 1/4 inch. There are 3 dots at 8 1/4 inch. And so that means there were 3 fish caught that were 8 1/4 inch. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 points on this line. And so that means that there were 12 fish caught. So, let's see my actual questions are: what was the length of the longest fish caught? And what was the length of the shortest fish caught? Those are my 2 questions. So, the longest fish caught, well, the larger numbers are up here. So the largest fish caught was 8 2/4 inch. The longest fish caught, there's my all caught, was 8 2/4 inch. What was the length of the shortest fish caught? 6 inches is the shortest length on this line plot. However, there were 0 fish that were caught at 6 inches. The shortest fish caught was 6 1/4 inch. So, the shortest fish caught was 6 1/4 inch. So it's really just a matter of taking the time to read the line plot. So let's read some more line plots. For 3 through 6, use the line plot below. My line plot, this is a line plot of giraffe heights. The giraffes are measured in feet. So this is 14 feet, 15 feet, 16 feet, 17 feet, and 18 feet. So, how many giraffes are 14 feet tall? At 14 feet, there's 1 giraffe, 2 giraffes. 2 giraffes are 14 feet tall. What is the most common height? So, the giraffes, let's see, there's 2 14-foot giraffes, there's 3 15-foot giraffes, there's 2 16-foot giraffes, there are 0 17-foot giraffes, and there are 2 18-foot giraffes. And so 2 giraffes are 14 feet tall. What is the most common height? The most common height would be here. This is the height that has the most giraffes. And so, the most common height is 15 feet. How tall is the tallest giraffe? The tallest giraffe is 18 feet. We will not do question number 6. Is 18 feet an outlier? We will not do question number 6. Let's keep practicing reading a line plot. For 7 through 11, use the line plot at the right. So I'm going to read. Oops. So I'm going to take a moment and read the line plot. These are the times for a 100-meter sprint. So people are running 100 meters and they're tracking their time. The least time is 10 seconds and the greatest time is 11 seconds. So let's see. Each dot on this line plot would represent a runner or a person, I guess. And so 1, 3, 4, 8, 13, 15, 18, 19, 20. I believe that's 20, yes. So there will be 20 people who ran the 100-meter sprint. Nobody finished it in 10 seconds. Somebody finished it in 11 seconds. Somebody finished in 10 and 7/10 of a second. 3 people finished in 10 and 6/10 of a second. 5 people. 1, 2, 3, 4, 5. Yes, 5 people finished in 10 and 4/10 of a second. And so, reading the plot. You know what it's for, you know what it represents, you know how it's measured. It's being measured in seconds. So how many people ran the 100-meter sprint? Oh, we just counted this up. It was 20. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Good. 20 people ran the 100-meter sprint. And not a single one of them was Miss Holly. 20 people ran the 100. Ooh, that 100 looks terrible. Okay, 20 people ran. Oh, that looks terrible, actually. I need to hold my pen. 20 people ran the 100-meter sprint. So which time was the most common? Most people finished in how many seconds? Most people finished in 10 and 1/4 seconds. Oh, no. 10 and 4/10 seconds. 10 and 4/10 seconds. Is the most common time. Which time is an outlier? We're not going to do the outlier questions today. How many more people ran 100 meters in 10 and 6/10 seconds than in 10 and 1/10 seconds? And so I find, on my line plot, I find 10 and 6/10 seconds. That's 3 people. And then I find 10 and 1/10 seconds. That's just one person. So my question is, how many more people ran 100 meters? So comparing the one here the 1 person here to the 3 people there. That will be 2 people more. Two more people. Ran 10 and 2 more people ran 10 and 6/10 seconds. Then 10 and 1/10, 10 and 1/10 seconds. Okay. Curtis said more than half the people ran 100 meters in less than 10 and 4/10 seconds. Do you agree? He says more than half of the people. Well, there's 20 people that ran. So saying more than half people ran, half of the people would be 10. So Curtis said more than 10 people ran 100 meters in less than 10 and 4/10 seconds. See how I took the time to really read that, not just call the words off the page. Curtis said more than half the people ran 100 meters in less than 10 and 4/10 seconds. Well, more than half, well, there's 20 people. So Curtis said more than half of 20 people. Half of that would be 10. So Curtis said more than 10 people ran 100 meters in less than 10 and 4/10 seconds. Do I agree? Well, just at a glance, I can see that most of the people are between 10 seconds and 10 and 4/10 seconds. But he said more than half the people ran it in less than. So there's the key. He said they ran it in less than 10 and 4/10 seconds. So he's saying more than 10 people ran 100 meters in less than 10 and 4/10 seconds. And so that means I'm going to ignore everything above 10 and 4/10, and I'm also going to ignore 10 and 4/10. So more than 10 people ran in less than 10 and 4/10 seconds. Well, that's 1, 2, 3, 4, 5, 6, 7, 8. 8 is not more than 10 people. Curtis is wrong. So, only 8 people ran so no, less than half. Less than half the people ran 100 meters in less than 10 and 4/10 seconds. So saith the graph.